Here we go. It's Monday morning. We got 4.1, some more notes on differential equations. And now what we're going to do is we're going to try to figure out what this C is when we're doing differential equations or solving some of the differential equations. But we need to have some initial conditions given to us to determine what that actual C is. And so you'll see what I'm talking about in this one problem right here. Let's just jump right into it. So let's say we know that g prime of x is equal to 6x squared, and we know that g of 0 is equal to x or negative 1. We want to find what g of x is. Okay, so the first thing we need to do is we need to take the antiderivative of this right here. So the antiderivative of this function, if we use that product rule, let's do it this way. G of x we know is equal to the integral of g prime of x times dx. So we got 6x squared times dx. Okay, and I know I can rewrite this as 6. I can bring the 6 to the outside, so I got 6 in the integral of x squared times dx. So we're just going to figure out what this is. Using the power rule, we have 6. That's from the outside right here. We got x to the n plus 1, which is 2 plus 1, all over 2 plus 1. This is equal to 6 times x squared all over 3. Why did I say squared? I meant to the third, guys. All over 3. And if we want to simplify that down, we got 2x to the third plus c. So our goal is to try to figure out what is this c right there. We want to figure that out. Okay? And they gave us some initial conditions right here to determine that. And the initial condition was we know that when g is equal to 0, the height is negative 1. And so we can use that. And this is how we're going to use that. We're going to take this 0 and we're going to plug it in for the x. And we know that this g of x right at the beginning, the height is actually equal to negative 1. So here's the equation we're going to set up. We're going to have negative 1 from this is equal to 2 times 0 to the third power plus c. And we're just going to solve for that c. Well, this is pretty easy because this is nothing. I got negative 1 is equal to c. So our g of x that we're looking for with the elusive c is actually g of x is equal to 2x to the third minus 1. There we go. And that's how you do a problem just like this example 1. Hopefully you have no questions on that. If you do, just so you kind of go replay this and see if you can figure it out. I'm going to try another one. This one's even harder. Example 2. Holy cow. They're giving us second derivative. They want us to go all the way and find the first function given the second derivative. Well, why won't my pen work? Oh, there's my pen's working now. Now, I guess we can do this. It shouldn't be too bad. We're just going to have to do what I did in the last problem twice. Okay, roll up the sleeves, get the kinks out of the neck, and let's go. Let's do this. Okay, so we need to find first the antiderivative of this. So the antiderivative of x squared would be x to the 2 plus 1 all over 2 plus 1. That is x to the 3 halves. No, x to the third over 3, and plus c. We know that this function goes through this point right here. This function goes through that point. So we're going to take this information, plug it in there. We got 0, or we're going to set this equal to 6. We got 6 is equal to 0. 0 comes from here. So the third over 3 plus c. Therefore, c is equal to 6. So our first derivative, not our second derivative, f prime of x is equal to 1/3 x to the third plus 6. Okay, now that we have that one, we are going to use this one to find the first derivative. So we bring it up here. I got 1/3 x to the third plus 6. We got to find the antiderivative of this. Well, what's the antiderivative of this? I'm not going to use it. Should I use the product rule? I could, but I can do it without the product rule. I got 1/3. This goes to the fourth power, x to the fourth. But if you were dropping down, you have 1/4 in front plus 6x. That's from this one right here. So this one right here gives us this, and this one right here gives us this. Let's simplify this down because it's crazy looking. 1/3 and 1/4, that's 1/12. X to the fourth plus 6x. Okay? So there's your antiderivative, but we know that this function right here, we need a plus c. We know this function goes through the point 0, 3. So we're going to say We're going to set this equal to 0 and plug our 0 in for the x right here and here and see what we get. So we get, what is it? 3 is equal to 1/12 times 0 to the 4th. You guys know that's 0 times 6 times 0, which you know is 0 plus c. So our c is equal to 3. Right there. Now let's just rewrite this formula right here with our c in it. So our f of x, which is what we were looking for, is equal to 1/12 x to the 4th plus 6x plus 3. There we go. And we got it. That's our function. That's our initial function, f of x, right here. Guys, on this problem right here, okay, I'm starting from scratch right here. We got a ball that's thrown vertically upward from a height of 10 feet with initial velocity of 60 feet per second. How high will the ball go? That's what we want to try to figure out. How high will the ball go? What's the top of this function? Oh, there's a lot to this. There's a lot to this. Okay. So what we're going to do is we are going to derive that position function that we used to just plug things in. We're going to derive this function using the antiderivative. And we're going to use the fact that this a of t, which is the second derivative of p of t, is equal to negative 32 feet per second squared as the acceleration due to gravity. So check this. This is how it works. We're going to start with this a of t. A of t is equal to negative 32. Okay? And we're going to find the antiderivative of this. We're going to integrate this. And when we do that, we get negative 32t, right, is equal to v of t plus c. Okay? Negative 32t plus c. So does anyone not understand? Hopefully you understand how I got from here to here. To take the antiderivative, you got to ask yourself, what the derivative of what will give you negative 32? Well, the derivative of negative 32t plus c will give you negative 32. So that's where I got this right here. Okay, now that we got this, we got to figure out what would this c be for this velocity, just like in the previous problem. Well, we know that the initial velocity at time 0, the initial velocity is 60. So we know that 60 is equal to negative 32 times 0 plus c. Therefore, c is equal to 60. So we know that our velocity function is actually not the general one, but the exact one for this situation is equal to negative 32t plus 60. Okay, but remember, our goal is to figure out how high this function goes, so we need to figure out a position function. So now we got to find the antiderivative of this. So to find the antiderivative of this, that will give us our position function. And the antiderivative of this one would be, if I bring this t, now this would be a t squared, and if t squared, there would have been 1/2, so this should be negative 16t squared plus 60t, that's the antiderivative of 60 right here, plus c. And one thing I do know is that my initial function, or my initial height at time 0 was 10 feet, right? So what I can do is I can plug 10 into this, and I can plug 0 into the time, because that was the initial time of nothing at time 0. It's at 10 feet, so I got 0 plus c here. And so I know that my c in this situation is equal to 10. So my position function, guys, that position function is equal to negative 16t squared plus 60t plus 10. Okay, so I got my position function right now, which is great. That's what I was working towards. This is necessary to determine what? Well, this is necessary to determine how high the ball will go. Well, we want to figure out how high this ball will go, so we need to take this and find the derivative of this and set it equal to 0. Well, shoot, we already did that, right? It's right up here. So we need to find when the velocity was 0. Well, that's easy. We'll just set this part equal to 0 right here. Okay? And we'll plug that point into this position function. So let's do that right here. Negative 32t plus 60 equals 0. So t is equal to 60 over 32. And 60 over 32 is really close to 2, right? Equals 1.8. Really? 1.875. This is 1.875. So at t equals 1.875, we know that this function was going to be at a maximum. Okay? do you have to justify this? Probably on an AP exam it might ask you to justify it, so you would take the second derivative, which is the acceleration, and notice acceleration is always negative, therefore the second derivative is less than 0, thus it being a maximum. So there's your justification there for you. But now we're going to take this 1.875 and you're going to plug it into the t right here and this t right here to figure out what we get. So I got p is equal to negative 16 1.875 squared plus 60 times 1.875 plus 10. Okay, and now we just got to figure out what this turns out to be. Negative, and this equals 66.25. So the max height of my function will be 66.25, where was it? Feet. At time 1.875. So these are the type of problems you're going to see on your homework tonight or today in class. Hopefully this video made sense for you. Stop it, fast forward it, rewind it, all that good stuff. But what's the homework assignment? Let's see if I can bring that up for you guys. Homework assignment is, and I quote, oh shoot, I closed it. Let me put, here we go. Homework assignment is 53 through 63 odd, 67, 71, 73, and 75. The sub I already told you this, but just in case she didn't, it's right here. Right there, okay? Well, anyway, I hope you all have a great day today. Tomorrow you will be doing an AP worksheet in class. It will be a multiple choice one, and you may not use your calculator because these problems will be just like on the AP exam where you cannot use your calculator. I want to make sure you're ready for this, okay? So hopefully this was helpful. I'll be sending out this link and a text message very shortly. I hope you have a great Monday and Tuesday. I will see you all on Wednesday.